Hello professionals, welcome back to my channel. In our APA interview preparation playlist, today we are going to look into service discovery. So let's get started, and I would like to thank everyone who are watching the videos and keep supporting me. Provide your valuable comments for more improvements. Okay, there are lots of topic to lined up. We'll get started. What is service discovery, and what is the problem it is really getting solved? Before and all, we used to have virtual machines, and virtual machines will be having static IPs. And if there is any communications needed, we'll be hard coding that static IP addresses, and we'll be communicating between two components, service, or two different projects, right? But nowadays, the industry has changed. Now, microservices has come into picture, and we might get lots of services. We have been cutting down, and we are splitting the single big project into different services, and we are deploying it individually, and there are lots of options for orchestrating that particular service. For scalability, if there is a particular service down, we got a hot oil techniques where the particular service will be coming up automatically. So in this situation, what happens really is every time when a service is getting up, it is going to be in dynamic IP. And say for example, service A and service B is getting communicated, and suddenly service B goes down, and it is restarted and it has came up, means it will be having a dynamic IP. So that service A needs to communicate to service B. How it can happen? How it will be aware about that dynamic IP? Okay, so here comes the problem. To resolve this problem, we got service discovery. Service discovery is nothing but a middleman between service A and service B. Okay, we will give the request data to that particular middleman. See, this is a request, and this is a payload. Go and find me the service. The service discovery will check on that list, and it will give the available service endpoints. Okay, so that service A and service B can be communicated without issues. So let's dive in deep. We'll see what is service registry and the discovery flow. Initially, it will be registered. Okay, there will be a registry, a central dictionary kind of thing. So if you are a client, and if you are going to produce something, and people are going to consume your particular service, then you need to make sure that you go and you register with that particular dictionary. Okay, who are required, they will come and they will find that particular IP addresses, and they will make use of it. The core problems what we faced before is hard-coded IP. When service restarts, IP may change, and the calls might broke. Manual updates needed for every deployment. It cannot auto scale new instances having new IPs, but without scaling options, nowadays microservice can't able to survive. So we can't able to go without auto scaling. Node load balancing. Before and all, if we have two services running, still we need to do that load balancing manually. Always we used to see that way, right? A particular service always gets the request from the servers, and one will be sitting idle. Like that and all, it used to happen. So if the IP addresses are being not coded, we might be facing these kinds of issues. And what is the problem it is solving is service registry automatically get the service addresses during the startup. Clients discover services at runtime, handles IP changes automatically, supports auto scaling seamlessly, built-in load balancing. Okay, these are the core principles, and this is how service discovery will work and will help us. Let's get into the types. We got two types of service discovery. One is client side, and the other one is server side. Client picks which instance to call. Okay, client will go, it will register, get that instance. Client chooses, call the instance. That's it. Okay, this is the client side discovery. And the server side discovery is load balancer will pick the instance. So there will be a extra component in between, and you give that particular request to the load balancer, and load balancer will do that routing for us. It will go and it will pick the services. Okay, but in client registry, we might define that particular thing. Say for example, WIP or VIP URLs will be there, and we might go and we can pick that. But we can make sure that service A communicates to this particular service B instance. Like that, we can make sure in the client side discovery. But in server side discovery, it is not possible, because a middle layer we got a load balancer and it will decide which one to route. Okay, so mostly it does the same work, but additionally we got a component in the load balancer area. And coming to the advantages, client has control over the load balancing, no extra op, no extra components. Okay, but the headache is each client needs their discovery logic. Everyone needs to write the discovery logic and they need to be handling everything, and it is language specific. When coming to the load balancer, it is language independent. Client just calls a load balancer, that's it. They don't want to worry about which instance and how to do that configurations and all. Everything will be kept ready and we can go and consume. That is what load balancer done. But the disadvantage is extra network hop. Always there is an issue, right? Whenever a new component is adding, it will reduce the development effort. It will be easy at the start. But a real challenge comes to the software industry is the maintenance phase. During the maintenance phase, every extra component we are adding, we need to maintain that component. Okay, so load balancer is one of the good example. If you add it to your network, then you need to manage it on your own. Okay, load balancer is an extra component. Yeah, that's it. This is the types of service discovery and key components. Service registry will be there, a centralized database kind of thing. It will hold all the services, IP address, porting, mappings, everything will be there. So that is what we call it as service registry. Service registration. Service tells the registry, I am alive. Here is my address. Okay, adding your host name to guest list, like that. Service lookup or service discovery. Here you are going and registering yourself. Here you are going and searching the right person. And health checks. Health checks is nothing but periodically in some seconds interval or some way we are making sure that that particular service, because we might configure a IP address, we are not sure, right, whether it is up or down. Without making that check, if you keep on diverting the traffic to that IP which is configured, either it is a dynamic IP also fine, but if you keep on diverting the traffic to that service which is down, then it is an issue, right? To overcome that problem, we always need to have an health check. Health check is nothing but every 5 seconds once you will go and check whether the service is up or not. Okay, so nowadays there are lots of inbuilt tools are there in all the languages, where they can just send out an health check message, and making sure that it will say that, hi, I am alive only, so you can divert the traffic to me, like that. So next one is load balancer, distributed request across multiple instances in the same service. Yeah, restaurant host seating guest at available tables. This is an good real world mental model. Okay, let's the next one is popular service tools. We got Eureka. Whenever people speak about service discovery, it is Eureka always. Okay, and HashiCorp also it is now getting into picture. Multiple people are using HashiCorp console, and it is good to use as well. Apache Zookeeper, who are used to Kafka or something, they might be aware. It is an distributed one, and it is quite handy for distributed things. If there are master and slave model, like that, multiple models it supports. So it is also a good choice. Apache Zookeeper. This is mainly for distributed coordination and strong consistency. Kubernetes built-in service abstraction environment variables. Okay, and AWS Cloud Map. It is also a cloud native one, and you already got AWS in their system already. They can go for AWS Cloud Map. Yeah, these are the various tools, popular tools in our industry. Mostly people will go for Eureka. They will have a server running and they will do that self-registration heartbeats and zone awareness. Zone awareness I will cover a little later. And there are two types of registration. One is self-registration, other one is third-party registration. Self, the name says, we go, we register our service. Orchestration, they will listen to a particular network, and if a new service is coming up, they'll go, they will get their IP address and they will put it into the register. Okay, there are two types. One is self and the other one is third-party. Kubernetes will do for us, but in self-registration, we need to go and inform the people. Like if you are using Eureka, you need to say that, hi Eureka, this is a new service I have born today, so you can use my IP address, you can start diverting the traffic to me. Okay, but in third party registration, Kubernetes will look into that particular network. If your service is up, it will go, it will automatically fetch IP address and it will put to the registry. Okay, these are the some of the interesting topic, and whenever you are coding or whenever you are developing a service discovery, this will come into picture. Mostly people will be used to hear this item round robin and weighted. Round robin is nothing but it is in round fashion. If there are three instances, first request go to A, second B, third request go to C. Again, the first request will go to A, B, C. Like that, what are the all the incoming request, right? It will be served in a round robin fashion. It will go server by server, so that the traffic will be evenly diverted. Okay, and weighted robin, it is different, it is a special kind of thing. So it is for heterogeneous instances. It will say, for example, different capabilities, like you need to write towards a particular service, so it will be having a different setup like CPU and everything. And if there is a read service, it will be having a different things. So for this combination of hybrid things, we can go for weighted robin. And list connection, send request to the list active connections. So it will look into the instance where nothing has been flowing. So it will divert the traffic to that. Long running request and variable processing times, best for. And random, it will pick random from the list and it will send to that particular server. It is simple to implement and good enough for most. If the traffic is very less and you don't want to say, for example, I worked on services per second, we will receive 300 requests. In that case, and all, we can't able to pick the random. Okay, we need to be very careful. Based on the traffic volume, you need to decide between these algorithms. If it is a small traffic, for per day itself, you will get around 100 requests, then blindly go for random. It will serve the purpose. It is simple, and always you need to keep in the mind, right? Whenever you are developing something or you are doing a architecture for a new service, you need to keep the things very simple. Don't add it because it is available. Okay, so that's the point I always used to do. Then consistent hashing, same user always goes to the same instance. This is also for some special cases we might record, so you can have this particular algorithm. Whenever we are touch basing that service discovery, we need to aware about zone region awareness discovery also. Nowadays, the particular servers are in cloud and cloud is in different zones, right? So we need to be aware about the zone also. So zone A, zone B, zone C is there, and zone our client prefers same zone to reduce the latency and cost. You got it right. Whenever if you give to the same zone, the hop will be less and it will be quicker, so that you can reduce the latency and the cost also. Nowadays, if there is a communication between different zones, the cost is slightly different, right? Because you are going to consume and you are going to use more resources. Whenever you are more using resources, then you need to pay for it. Prefer instance in the same zone, and if no healthy instance, then you can go to the different zone as a fallback. But always have prefer the instance in the same zone. That is the key principle of zone awareness routing rules. In Netflix, Eureka, ribbon with zone preference server list, it can be used. There are other options as well. Nowadays, this is a popular topic because now cloud and all came into picture. So this is getting popular, and many frameworks has come into picture. Apart from this Netflix Eureka, you can go and you can search by yourself and make sure that you are doing it. If you are going to plan a service discovery and it is in cloud, then you need to pick and you need to be aware about the zone preference server list filter as well. Okay, tool compareness, yeah, cap. Whenever we are working on the server deployments, these things and all, whenever we are discussing, right, cap will come into picture. And yeah, cap I will have a separate video. For now, Eureka, Consult, Kubernetes, and Zookeeper, they are given a quick comparison and how it can be used, and for what and why we can use this ones. You can hold on and pause the videos and you can quickly check that metrics. And yeah, coming to the advantages: no hard-coded IP, seamless auto, self-healing, load balancing, zone region awareness of routing, canary deployment support, additional infrastructure complexity, registry is single point of failure, network latency, Single point of failure if it is not clustered, and the caching can lead to stale data, client side logic needed, learning curve for new team members. If there is a new component to maintain that, you need to learn something, right? And if there is any issues or something, then you need to be on your own, because because anything can happen, right? You might not find the people who have worked in this niche technologies. So interview power phases, service escape enables dynamic routing in cloud environments. Service registry and startup and client discovery them at runtime, no hard-coded IPs. Registry must be highly available. We run a cluster with multiple nodes, zone-aware routing. And yeah, coming to the conclusion, service registry, phone directory of a service, quick mental models. Registration, I am alive, use me. Discovery, where is this service X? Health check, heartbeat or keep alive. Load balancer is a traffic distributor. And mental models, Google Map, it is a Google Map for microservices. If you need to go from this place to that place, then you will open a Google Map, right? In the same way, from service A to service B, if you need to communicate, it is the path for us. It will give the path for us how to communicate. In registry, it is like a phone directory, yellow pages. Registration, adding name to the guest list. Health check, security guards checking the badges. They will stand and they will check, right, in the same way. And yeah, that's it. One-liner service discovery lets services find each other without hard-coded addresses. Essential for cloud and Kubernetes environment. Okay. So you might not face multiple questions on this area, but definitely you need to be aware about the basics. Hope I have covered the basics now. Okay. Yeah. Thanks. We'll meet in the another video. Thanks. Thanks all. Bye.